LDR explained. The LDR stands for photoresistor, okay? A photoresistor, or LDR, stands for light decreasing resistance. So LDR stands for light decreasing resistance or light dependent resistor. It is an active component that decreases resistance with respect to receiving luminosity, that is the light, means the light, on the component's sensitive surface. So that means that the resistance of the LDR decreasing with the density of the light on its sensitive surface. LDR sample. The American standard sample and the international standard sample. These are the two samples of the LDR if you are seeing them in the circuit. So that means that this is an LDR, light dependent resistor or light decreasing resistor, and that this is the LDR in the real life. Okay, that means that is the physical LDR. There are somebody that uses these samples but without the circuit that surrounding the resistance. Applications of photoresistors. Photoresistors are used in street lights to control when the light should turn on and when the light should turn off. When the surrounding light falls on the photoresistor, it causes the street light to turn off. When there is no light, the photoresistor causes the street light to turn. This reduces the wastage of electricity. They are also used in various devices such as alarm devices, solar street lamps, night lights, and clock radios. LDR resistance. Its resistance starts from very low resistance depending on the strength of the light and ends with 100 mega ohm. Could be more depending on the strength of the darkness. So that means that when the resistance of the LDR is very low depending on the strength of the light. So when there is a light, very strong light, the resistance of the LDR will be very low. If the darkness is very strong, the LDR, the resistance of the LDR will be very high, up to 100 mega ohm. 100 mega ohm means 100 million ohms. That's it in this lecture. See you in the next lecture.